Hello, I'm Dr. K, and I'm going to be going over some of the questions from the June 2025 Regents exam. So let's get started. The first question is number 51, and we are going to look at this question, which requires us to also peek at Table F. So it says, based on Table F, identify one positive ion that forms an insoluble compound with iodide ions in an aqueous solution. And so we have our solubility guidelines right here. Now this table is used a lot when we want to determine if something is soluble or insoluble. Now on this side of the table, we have ions that form soluble compounds. And then we have exceptions. So any of these exceptions mean it's no longer soluble, it's insoluble. On this half of the table, we have insoluble compounds. Any of those exceptions are going to then be soluble. So exceptions flip what is on this side. So if it's soluble, it flips to insoluble. If it's insoluble, it flips to soluble. Let's find our iodide ions. So in this case, we're looking for the iodide ions, and that's going to be right here with the halides. Now it says halides, chloride ions, bromide ions, and iodide ions. We're interested in the iodide ones, but they are all together as far as solubility. Now, generally, these are going to be soluble. It says up here that they're going to be soluble, but there are some exceptions. There are 3 exceptions: silver ions, lead ions, and mercury 2 ions. So in this case, we can put any of these 3 ions for our answer to this question. So any of these 3, they're only looking for 1, so you can put Ag+, which is silver. You can put Pb2+, which is lead, or you can put mercury 2+. Any of these 3 options will be the correct answer for this question. Now moving on to the next portion. On this one, we're given another table. It says subatomic particles in 4 different atoms. So we have atoms L, M, Q, R. Now in this table, it tells us our number of protons, our number of neutrons, and our number of electrons. We need to answer some of these questions below. So our first one is state the number of valence electrons in an atom of M in the ground state. So let's find atom M here. Atom M is right here. I'll draw a little arrow. It has 33 protons, 32 neutrons, and 33 electrons. Now, because we have the same number of protons and electrons, we know it's neutral. All of these are actually going to be neutral because they have the same number of protons and electrons. We have 32 and 32, 33 and 33, 33 and 33, 34 and 34. If you have the same number of protons and electrons, you have a neutral atom. Neutrons are neutral in themselves, but protons are positive, electrons are negative, so these are all neutral atoms. Now this is asking about valence electrons. We know that we have 33 total electrons, but one of the ways that you can answer this is go into your reference table and go to the periodic table. We're looking for something with 33 protons, so we are going to go down until we find the element that has 33 as its atomic number, which in this case is arsenic. Let's figure out how many valence electrons arsenic has. The way that we do this is we count over. This column has 1 valence electron, this column has 2, we skip the transition metals, then we have 3 valence electrons, 4 valence electrons, and then finally 5 for this column. So in this case, this one, because it's in this column with nitrogen, phosphorus, and so forth, these all have 5 valence electrons. We would write 5. So this one for M has 5 valence electrons. Now for our next question here, it says compare the mass of a proton in an atom of R to the mass of an electron in an atom of R. Now this is true for all protons and electrons. It's not something that is specific to R, for example. Protons are much, much larger than electrons. So we would want to say protons are larger. Or protons have a greater mass than electrons. Now this is true for all of them. This is not specific to R. This is true for all protons and electrons. And then finally we have our next question. Write the two letters from this table that represent atoms that are isotopes of the same element. Now when we're talking about isotopes have different neutrons, but they always have, if they're isotopes of the same element, they should have the same number of protons. So we're looking for same number of protons, and then for them to be isotopes, they need to have different number of neutrons. If they had the same number of neutrons, they would just be the same atom, or same, isotope. But if we want different isotopes, we need different number of neutrons. So in this case, we're looking for two that have the same number of protons. We're going to go to our table. We have 32, 33, 33, 34. Well, right off the bat here, we see that we have two that have the same number of protons. And then over here on neutrons, they have a different number of neutrons. So our two letters that represent atoms that are isotopes of the same element are M and Q. I hope this helps with this question and going through some of those subatomic particle definitions.